In today's data structure class, we will see the circular queue from second unit. And in this class, we will see the definition of and the operations. Like normal queue, here also we have enQueue, deQueue, front and rear. After that, let us see some of the applications of circular queue, then the advantage and disadvantage of circular queue over the normal linear queue, right? So these are the topics we will see in our today's class. Now let us see what is circular queue. Circular queue is a special case of simple queue in which the last member is linked to the first member. Okay, that is, see, this is the day of week, days of week. Okay, here the last member Saturday is connected to first member Sunday. Okay, the members are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. After Saturday, there is no gap. There is no gap between last node and first node. That is, the last node is connected to the first node. This is otherwise called as ring buffer. Okay, the nodes are connected end to end. Hence, it is called as ring buffer. Here, the insertion taken place at the front of queue and deletion at the end of queue. Like the normal linear queue, the insertion and deletion operations are same here. The insertion will taken place at front. See, this is front. Insertion will taken place at front and deletion will taken place at rear side. Next, let us see the representation of circular queue. It is also the abstract data type. It shows only the abstraction of the implementation. We cannot see the complete implementation here. The pointers of queue are front and rear, like our normal queue. Okay, here the front points to the front side of queue and it is used for delete operation, that is dequeue operation. And the rear, this pointer points to the last item of the queue, which is used for insertion operation, that is enqueue operation. See in this diagram, the last node is connected to the first node and the front pointer which points to the first item in the queue and the rear pointer which points to the last item in the queue, and these places are empty. Once the front and rear pointer reached the size of queue, here the size of queue is 7, right? See, once they reach the next, they will reset to the first item. Okay, that is the initial state. Okay, so initial value will be again reset to the front and rear pointer. Hence, the insertion operation and deletion operations can be done continuously, unlike the normal linear queue. So this is linear queue. Here, once the rear reached the last item, that is end of queue, then we cannot insert the new item further, right? Because the queue ends here. But this is not in the case of circular queue. Once it reaches the rear, if this place is vacant, then we can insert new item here, right? Next, let us see the operations of circular queue. Here, the first one is front. Front function that returns the element at which the front pointer is pointing. Okay, this is front item. And rear, this function is used to print the last element in the queue. Okay, and enqueue, as usual, this is used to insert a new element in the rear end of the queue. Okay, it is at the last queue. And dequeue, which deletes the first element in the circular queue in the front side. Okay. First, let us see the enqueue operation. enQueue operation used to insert a new item in the circular queue. So before inserting any new item, first we need to check whether the queue is full or not. If the queue is full, then print overflow error message and exit the program, because we cannot insert any new item if the queue is full, right? If queue is not full, then we need to check whether rear equal to size of queue, that is rear reached in this point. Okay, then we need to reset the rar value into 0, right? And increment the rar pointer to the next empty place. Otherwise, suppose if it is here, then rar pointer should be incremented here. Okay, and add the element in the position. So in this position, we need to add 55, for example. Okay, and return success. So this is how we need to insert a new item into the circular queue. Okay, first we need to check whether queue is full or not. If queue is full, then overflow message should be displayed and exit. If it is not full, check whether rar reached the last pointer, and then we need to reset the rar pointer to the initial position. Okay, otherwise the rar pointer should be incremented, and here we have to insert our new data item. Okay, and this is the pseudocode for enqueue operation. Enqueue of circular queue and item. So this is array, and this is data item to be inserted. Okay, now number of items equal to size minus 1. Here our size is 8. If number of items reached the size, that means all the data items are filled over, then we need to print the queue is full. Else, if rar equal to size minus 1, rar reached here, then rar will be reset. That is rar equal to 0. Otherwise, rar equal to rar plus 1. Rar will be incremented here. Okay. Circular queue array of rar in this place, we need to insert the new item. Okay. 55 will be inserted here, and number of items will be incremented by 1. Okay. So the number of items, now the total items are 6 items are there. Okay, 1, 2, 3, 4, 5, 6. So this we need to maintain in the circular queue, right? Otherwise, the all operations are same as linear array. The next one is dequeue operation. In the dequeue operation, which is used to delete an item from the queue, right? See, before deleting any item, we need to check whether the queue is empty or not. If queue is empty, then print underflow error. Okay, because the queue is already empty, we cannot delete an item. Then exit the program. Okay, if queue is not empty, then access the data where the front is pointing. Access the data where the front is pointing. Okay, increment the front pointer to the next available data member. Okay, next increment the front pointer here. Now this is front. Okay, if front reached size of queue, suppose if front reached here, okay, already front reached here, then reset the front value to the initial value. That is, the front should be pointed here. Next, so front pointer 7 will be reset to front equal to 0. Okay, then return success. So this is dequeue operation. And now let us see the pseudocode for dequeue operation. And dequeue, it accepts two parameters. First one is this circular queue array, and this is data item to be deleted. Okay, item. If number of item equal to 0, number of item means there is no item in the queue, then it will print queue is empty. Else, item equal to circular queue of front. So the circular queue of front will be copied into item that to be deleted, and number of item will be number of item minus 1. So the total number of items will be decremented, and if front equal to size of front, if front, that is if front point is here, then front equal to 0. The front should be here, isn't it? That should be reset to 0. Otherwise, front equal to front plus 1. Otherwise, front will be incremented here. Okay. So this is dequeue operation in circular queue. Now let us see some of the advantage of circular queue over the linear queue. And this is the example for linear queue, and this is circular queue. Okay, circular queue. When come to linear queue, the size is fixed Hence, when rar pointer reaches the end of queue, the insertion is not at all possible. If the rar reaches the end of queue, for example, this place, fifth position, after this we cannot insert any new item, isn't it? See, when come to circular queue, if the rar reaches end of queue, then immediately it will move to the first position of the queue. This one, circularly. Hence, the insertion is also possible till the queue is full. Queue is full. Okay, that is full capacity utilization is possible in circular queue. The next one is easier for insertion and deletion. In circular queue, if queue is not fully occupied, that if there is any empty space, we can easily insert a new element in the vacant location. Okay, see, if there is a vacant here, then we can easily add new item in the circular queue. And the performance is better when compared to linear queue. Here, the queue offers better performance in the situation where the data is frequently added and removed from the queue. Okay. For example, if these data items frequently removed, then in this place we can easily insert new items. Okay. So this is not possible in the linear queue. And the next one is simplified implementation. See here, implementing circular queue is very simpler. It requires less complexity and few conditional statements. Okay, and improved flexibility. So with circular queue, the front and rear pointers moved in circular direction. This is very important here. Okay, so the both pointers will move circular direction, which allows greater flexibility in implementing the queue operations, especially the insertion operation and deletion operation. The next one is reduced overhead. That means the circular queue is fixed size, so we need not allocate and deallocate memory continuously when compared to the dynamic data structure like the linked list structure or linked queue structure, linear queue structure. Okay, because the size is fixed here. And this circular queue can be used for both the FIFO structure and LIFO structure. That is first in, first out and last in, first out. We can use this circular queue for both structures. And it is easy to implement and understand. And this circular queue supports circular buffering for streaming data applications. So these are some of the advantages of circular queue over linear queue. Next, let us see the disadvantage of circular queue over the linear queue. Right? So it has limited capacity which leads to overflow and data loss. So this drawback is for both a circular queue as well as linear queue, right? And when come to circular queue, it requires additional logic to handle empty and full states. Okay, we cannot only depend on front and rear here. We need some additional logic whether the circular queue is full or empty state, right? Hence, it is more complex when compared to simple linear queue. And it is difficult to debug if there is any errors. And this circular queue is slower when compared to linear queue. Next, let us see the applications of circular queue. The first and most important application is memory management. So the circular queue helps better memory management when compared to linear queue because we can fully utilize the memory. Okay, in circular queue because the rear and front pointers move circularly, hence the utilization of queue will be very high. And second one is CPU scheduling. Okay, so the process will come to the CPU for execution. CPU, this is process. When process enters, then that will wait in the wait queue. That will wait in the wait queue. Okay, once it turns completes, once the time slot is completed, then the process will go back to the queue again. The same process will go back to the queue again. Okay, so in CPU scheduling, the circular queue is very much important. And the next application is traffic system. In computerized traffic system, the circular queue is very much helpful to switch between the different traffic lights. For example, red light, green light, yellow light. Okay, after yellow immediately red will come, isn't it? So the circular queue is very much helpful to switch between different lights in the traffic system. So far we have seen the circular queue from second unit, and in this class we have seen the definition of circular queue and the operations, especially the enQueue operation and deQueue operation. After that we have seen some of the advantages of circular queue over the linear queue, as well as the drawbacks, and then the applications of circular queue. In the next class we will see the priority queue from second unit. Thank you.